Okay, this is the M1 paper from October 2023. This is question number 2, and this is an acceleration time graph here, but we'll do a velocity time graph, we'll do some kinematics, some SUVAT work involving this scenario. We've got this car which is moving from A to B. If this is the acceleration time graph, I know that it's decelerating for the first 4 seconds, then it's moving with a constant speed, there's no acceleration there at all, and then finally for the last 10 seconds it's accelerating at 1.2, and it gives me information here, tells me what the speed is at A, and asks me in particular to work out the speed at the end of the 20 seconds. Right, okay, I can do that. What I need to do then is to think about this as a journey in 3 parts, from 0 to 4 seconds, 4 to 10 seconds, and then 10 to 20. So let's set up our SUVAT for our first 4 seconds. Make it clear to the examiner. T equals 0 to 4 seconds. So what have we got? We've got, if I put my SUVAT in, it tells me in the question, if you go back and look, that the initial speed, the initial velocity is 8. I want to work out what the velocity is at the end of those 4 seconds. We know that the acceleration is minus 0.5, and we know that t is equal to 4. So if I've got u, v, a, and t, then the SUVAT equation that I'm going to use is v equals u plus at. So v will be equal to 8 plus minus 0.5 multiplied by 4. So that means that v works out to be equal to 6 meters per second. So just go back up and put on here. We were traveling with u equals 8, but at this point here now we've got that v is equal to 6 there. For the second part of the journey, from 4 to 10 seconds then, t equals 4 to 10 seconds, there is no acceleration. So if there is no acceleration, and I want to work out what the speed is at the end of that, we're just going to get v will be equal to u there. So v will be equal to 6 meters per second at the end of that time as well there. So we've got our u here is going to be equal to 6. So let's look at the last period of time, which is from t equals 10 to 20, from t equals 10 to 20 seconds. What have we got going on for my SUVATs? So what we'll have at this point is that u is the v from the previous part. U is going to be equal to 6. V is what I'm trying to work out. We know now that it's accelerating at 1.2. And just be careful here. T is 10 seconds. The duration of that journey is 10 seconds there. Again, we've got v, u, a, and t. So we've got v equals u plus at. So if we just sub in what we know here, v is going to equal to 6 plus, and then it's 1.2 times 10, so v works out to be 6 plus 12, which means v works out to be equal to 18 meters per second, which is what they asked us to do for part A. For part B then, it says, can we draw or sketch the speed time graph? Yeah, let's just think about what we're going to do for this one then. So obviously, velocity at one side, time at the other here. So it's a speed time graph I'm doing. And from what we were told, we knew that it was decelerating. It started off at 8 and it decelerated down to 6 meters per second. And in doing that, that took 4 seconds. Then we had it just staying at a constant speed between 4 and 10 seconds. And then we know it's accelerating, and we know it's accelerating at a steeper angle. Obviously, it's 1.2 is the acceleration, and the deceleration was minus 0.5. So just, it doesn't need to be perfect, but just make sure you've got some of those key things in there. And we know that's 20 seconds there, and we know that goes up to 18 meters per second there. So as long as we've got all those 3 different parts relatively accurately drawn, that's good enough for the speed time graph. What does it ask for part C? For part C, it says, can we find the distance that it travels? So the distance that it travels is just going to be the area under the graph. So distance will equal area under the graph. Okay, so it's this trapezium here, this rectangle here, and this trapezium here. I'm going to get rid of those. In fact, no, I can leave them on there, I guess. So area 1 is going to be just half A plus B times H. And what have we got there? We've got half, one length's going to be 8, one length's going to be 6, and the width of that is 4. So whatever that works out to be, that works out to be 28 metres. Area 2 is just base times height, and that's 6 across and 6 up, 6 times 6. So that's 36 metres. And then area 3 will be half A plus B times H again. This time we've got 6 and 18 as my two heights on there. 6 plus 18, and the time was 10 there. So that works out to be 120 metres. So AB works out to be 20 plus 36 plus 120, which works out to be, 28, apologies, 28 plus 36 plus 120, which works out to be a distance of 184 metres. So yeah, quite an interesting question that we don't very often have the acceleration time questions there, but hopefully that will make sense. Yeah, that's a good question for you to have looked at before the exam.